Welcome to Enviro Close-Up. I'm Carl Grossman. The Romans started it. They took sewage and they just dumped it in any nearby body of water. Well, an ecologically sensitive, an ecologically sensible new idea has come along in terms of dealing with sewage. And with us is Phil Henderson. He's the Chief Executive Officer of Ecological Engineering Associates. They've been developing this new way to deal with sewage. And Bruce Strong, he's the Director of Operations of the Massachusetts-based company. Phil, how does your treatment program work?
Carl, what we've done is developed a technology that essentially replicates the cleaning power of nature. We are replicating what freshwater streams and natural marshes and wetlands can do, and they've been cleaning waste for a long time, and they do a very effective job, providing that they're not overloaded. And of course, what's happening to our continent as populations increase and densities increase in certain areas is just that we get overloaded. We've seen a need for the ability to take sewage and septage and to be able to turn it back into reclaimable water that can be used within the community, either to recharge a drinking water aquifer, used to water crops, vegetation, and not treated as waste. There's very little waste in wastewater. We look upon it as a resource, and we want to reclaim it. Our technology is different in that we don't have a lot of mechanical, chemical components that are going through some process to try to clean the water. We have what we like to term living machines, which are essentially the ecosystem within the wastewater treatment plant, principally bacteria, along with a large number of plants. As we get down the process, which is really a food chain, we're putting our system, which is these biological components under cover of a greenhouse in most cases. Our logo is greenhouses that grow clean water. The purpose for the greenhouse is to protect the biological system from the extremes of the environment.
Bruce, go through the elements of the process.
What you basically start with, we do share some concepts in common with conventional wastewater treatment plants. The stuff that comes down still has to be screened of large objects. You have to take out sand and grit, which could damage your pumps, but that's usually where we leave the process. If we're dealing with sewage, we bring it right into the treatment plant. We don't have what's called a primary settling step. All the material that's in there we consider food. It goes into clear-sided tanks that are aerated. The clear side allows for algae to grow on the insides. We have snail populations that then feed on the algae. The surfaces of the tanks are all vegetated. We use a variety of plants: water hyacinths, willows, water poppy, water mint. We go through a series of these aerated tanks. Well, we get to them later on.
Carl, let me ask you a question. How would you like to have a wastewater treatment plant built in your neighborhood, in your backyard, from your normal image of a wastewater treatment plant?
Absolutely not. I mean, they smell. You end up, like I live on eastern Long Island, where you have a number of sewage treatment plants that have been spewing out nitrate-rich effluent, just partially treated. I think it's called secondary treatment as opposed to tertiary. But reading the literature from your company and hearing about it from you guys, and I mean...
Let me take your hometown there as an example. No one there would want a wastewater treatment plant because of the image it has. But what's happening is, in most towns in Long Island, they're pumping the sewage over to the coastline, to a treatment plant. They're treating it, and they're putting that treated effluent out in Long Island Sound. As you say, it's secondary, so it's got nitrates, which are, there's a problem there. Nitrates are toxic in drinking water to small children. The other thing that's happening is you have a sole source aquifer that's supplying the water on Long Island. You can't keep pumping the water out forever and dumping it in the ocean without dropping the level of your aquifer in your drinking water supply. So, that's a paradigm that doesn't work very well. Intersolar aquatics, part of our concept, big part, is that we can empower local communities because our systems are attractive, they're very good neighbors. In fact, they become an environmental education center in addition to making very, very clean water. We can treat to drinking water standards so that you can put the water without the nitrates because we've taken it out essentially in the form of nitrogen gas, which is going back to the atmosphere. And you have clean water you can put back into your drinking water aquifer. We have communities, and I never cease to be amazed. Certainly, it makes me feel awfully good as to how these communities embrace our systems. They become something that the towns are proud of, and it's a real asset.
Phil, the thing that doubly impresses me, I mean, among the many impressive features of your process, is the fact that it can be done anywhere. Years ago, in fact, as a print journalist, I did stories on the Reed Trench system. This is about 25, 30 years ago. There was a system, I don't know exactly the name, something about a pond. But I mean, here were people trying to, through reeds, through the natural ecosystem, cleanse polluted water or sewage or what have you. But they were limited in terms of the time of the year. By injecting a greenhouse into the system, I mean, it can happen in Nova Scotia, which gets pretty cold in February.
Yeah, you're right, Carl. The concept of natural systems is to basically take nature and put some wastewater in it and see what comes out the other end. And both ponds and marshes, and nature, given enough time and space, will clean it. But you're looking at, if you've got an extra 50 acres or 100 acres to clean some wastewater, it's cost effective. Also, the environment is critical, as you mentioned. You have to be in a California or a Florida environment. It's not going to work anywhere. So, we took that variable out. We also combined the knowledge that the engineering community had developed over the years in treating wastewater. So what we've done is we've combined the natural part with the, let's say, the professional, conventional part, and we've come up with an improvement on both, put them together so that you've got a reasonably small footprint and you've got a very cost-effective system that can work virtually anywhere.
And where could people get in touch with Ecological Engineering Associates?
Well, our office is in Marion, Massachusetts, 13 Marconi Lane, and we answer every phone call. And we love to have people call us. We give tours of a number of our plants, and we're quite busy. Our phone number is 508-748-3224.
Thanks so much, guys, for being here, and keep treating sewage in a very, very sophisticated and in a very sensitive way. Thanks for watching.